This is a classic car blinker circuit with incandescent bulbs just like they came from the factory. 1157 in the rear, 1157 in the front, a 194 as a side marker, and this is on 194, it would be the dash indicator. Everything blinks together. When you turn the running lights on, both sides come on, and you see that this and this alternate. This is your front marker, this is your side marker, this is your dash indicator, and they alternate. That is the factory behavior. Let's see what happens when you put LEDs in here. All right, now we've got LEDs. Let's turn it on. These are our running lights, and let's see how it looks. It looks right, except that your blinker indicators for right and for left in the dash are faintly lit up. They're not supposed to be when the running light is on, obviously. When you do turn your blinker on, these are alternating, but this one here is not flashing. This one's not flashing like it's supposed to. That's not correct. When you turn your running lights off, this looks like it's working. These are flashing together. Dash indicators flashing, this is flashing, but you're also getting some flashing on the other side over here, which you're not supposed to have. So just a direct swap of LEDs in, you're going to have issues. It is not going to work. What is the solution? I'll tell you what the solution is. The solution is you need to put a resistor on both the running light and the turn signal wire of your front 1157 bulb to ground, and then it will work correctly. You can keep the original thermal flasher if you'd like, because you'll have enough resistance to cycle it, or you can put an LED flasher with a ground in, but it's not required. If you add the two resistors to your front 1157 bulbs, you will maintain all of the factory functionality of the incandescent bulbs. You'll get the alternating flash when the running lights are on. You won't get the bleed over into your dash indicators or to anywhere else in the circuit, and everything will work fine. Let's demonstrate adding those resistors, and we will see that it works. I've already got the resistors in here going to ground. I'm going to take one and I'm going to connect it to the blinker circuit. I'm going to take the other and I'm going to connect it to the running light circuit. People will say you just need to get rid of the thermal flasher and you need to put an LED flasher in. Let's go ahead and make that swap and we will see if it makes any difference. We've just put in LED flashers, which are solid state. They do not require a certain thermal level to operate. They do require a ground. So if you put them in your truck or your car, you will have to connect them to a ground somewhere. And they just have a preset time on them, and they're going to flip on and off, on and off. So right-hand circuit, no resistors. Left-hand circuit has resistors with LED flashers. Let's see if our right-hand circuit works correctly. It's working correctly with just the blinker, but when you turn the running lights on, all of a sudden you have trouble again. So just the flasher is not going to fix your problem. We also have that on the left-hand side. You can see that the left-hand side is flashing like it's supposed to. When you're turning running lights off, it also flashes like it's supposed to. Works just like factory with LED flashers. Stick around and let's talk about why that works and what doesn't work. You may be asking yourself, Kenny, what is this contraption? And what I have done here is I have recreated a factory classic car circuit. This is based off of my 1987 Silverado, but there's lots of cars from that era that work the same way. If they have 194 side markers in the front and they alternate between the sides, I built this to test different bulbs and different solutions instead of having to continue to butcher the wiring on the truck every single time I wanted to try something new. I built this and it's a recreation of the functionality, so I was able to determine what the solution was and then execute it on the truck, and it worked flawlessly on the truck after trying some different things on the truck that didn't work. I've seen this question asked a whole lot. I put all LED bulbs and now my blinkers don't work, or it's lighting up my dash indicator, or they're having all these host of issues and they're always looking for a solution. Sometimes it will be recommended that they swap out for an LED style flasher like this with a ground. Sometimes it's recommended that you put a resistor somewhere. Sometimes it's said that it doesn't work, it can't be done. People say just leave an incandescent bulb in the 194 side marker and that will take care of it. I wanted to get to the bottom of there's got to be a solution for this, and so I built this as a recreation of the circuit so I could test here with cutting wires. You can see how many splices. This one was soldered and then it was butt spliced. This one was butt spliced and soldered. I've hacked into this and I've tried different things in different positions until I determined exactly what the solution is so that I can give a definitive answer. So anyone who's chasing their tail like I was, then this will be a resource for them, hopefully. So this has resistors on the left-hand circuit, no resistors on the right-hand circuit with the factory-style thermal flashers in it. We can see what happens. If you're not familiar, the way that the old-style thermal flashers work is there's enough resistance in the circuit that they heat up, and there's a filament that heats up. When it heats up, it disconnects. When it cools off, it reconnects, and it does that over and over and over again. So without enough resistance in the system from LEDs, which draw very, very little resistance, that's why those don't like to work, and that's why they make LED flashers. This 194 here is finally generating enough heat so that you get a slow blink from the factory-style thermal flasher. This side with resistance, you can see that you get a more appropriate flash on this. You can see on the power supply here that when it flashes, it's drawing about 3 amps to light these up with the resistors and this 194 bulb. When we flip on the right-hand side, you're only drawing about a half an amp to get them to light up. One thing to note about this, even with the resistors like we have on the left-hand side, the 194 LED replacements that you use up in the front for your side markers have to be bipolar. I think that's the right word. I'm not talking about that one coworker that you have bipolar. I mean that regardless of which side you apply voltage to, it will light up. There are some that are directional. You have to make sure you put positive on one side, negative on the other, otherwise they do not light. That will not work here because this socket alternates being powered from one pin and the other pin, and the ground switches between the two of them. So the LED has to be able to function from either direction. For your rear markers, it does not matter. Those can be single polarity because these do not blink. They only act as running lights. Your dash indicators can be single polarity because they only blink, they don't act as running lights. These, since they do both, they have to be powered from both sides. You just have to check the spec before you buy a 194 bulb. It's hard to tell just by looking at them. You can see these are 5 different ones that I've tested. This one works both directions. This one works both directions. This one does not. This one does not. And this one does. You think you might be able to tell this one's just got one little wire, this one's got 2 wires. This one is bidirectional, this one is not bidirectional. So, why do incandescents work and LEDs do not? It has everything to do with the path to ground for the voltage when applied to the bulbs. This is your just classic incandescent filament 194 bulb, and if I measure across, if I touch across the pins, this meter's just set to test continuity, and it beeps saying that basically that there's a contact. When I touch these together, it beeps. Whenever I touch these wires on either side, it beeps. When you put an LED in, you've got your contacts here. This beeps. When you touch your 2 contacts, there is no beep. So this bulb will not act as a path to ground. That's the entire issue of why LEDs give problems in these old school setups. This is the resistor that I'm using. This you can pick up at any auto parts store. This is a 6 ohm, 50 watt, and it's going to be sold as a LED load stabilizer or something along those lines, but it is just a resistor. When you mount these, make sure that you mount them flush to metal, put a couple of screws in them to hold them. They do get extremely hot because what they're doing is they are adding resistance to the circuit, and for lack of a better term, electricity goes here to die. It gets dissipated as heat. So the only way to get rid of the energy, since you're not using it at the bulb, is that it has to be dissipated through heat. That's why they're in these little aluminum heat sinks. Just don't put them anywhere where you're going to accidentally touch them after your lights have been running, and make sure you mount them somewhere where they get good airflow if you can. Definitely mount them against metal to help act as a heat sink and dissipate heat. They are a wear item. These will die after a while, depending on how much you use your lights, how much you drive your vehicle. They do eventually burn out, and you have to put new ones. If you want to install them with some type of quick connect in case you ever need to replace one instead of splicing wires every time. They usually do come with T-taps. I'm not a big fan of T-taps, especially when you're generating resistance. I don't know exactly what the resistance across this wire is, but with T-taps, it's such a tiny contact with the existing wire. I would definitely recommend cutting it and then butt splicing it in or soldering it in. Okay, to explain why LEDs are a problem in these old classic cars, I did a SketchUp of roughly what the front blinker circuit looks like on at least GM trucks, probably lots of other things too that have these side markers in the fenders. This isn't exactly the way that it's wired up, but this will explain well enough what is going on. This is the pertinent parts of the circuit we need for this explanation. From the factory, what you've got, your 1157 bulb in the front has two filaments in it. It's got a blinker filament, and it's got a running light filament, and it's got a ground, 3 wires. The 194 that's on the same side in the fender is wired in series with the 1157. What happens whenever you turn on the running light, so you apply running light power, you get your running light filament that lights up, it connects to ground. You also get running light power to your 194, so it lights up. And because there's a filament that provides continuity across here, then your blinker power wire becomes your path to ground. So you get 12 volts here, you get ground here. It passes through the 1157 blinker filament and it's able to get to ground, so this bulb lights up. When your running lights are not on and you turn your blinker on, you get alternating 12 volts on this line and it just works in reverse. You have your path to ground, it comes through your running light, and it goes to ground here. So both of these blink at the same time when the running lights are not on. The 194 bulbs on the side have 2 wires. People would assume that it's going to be a positive and a ground. It's actually 2 positives, and they alternate which one is going to be the ground based on which one of the positives is powered up at any given time. So why do they alternate when the headlights are on? You get running light power here, you get power here, you've got path to ground, they're both lit up. Then you turn on the blinker, you get power here, it lights up the blinker filament, it goes to ground. When that is lit up and going to ground, there is no path to ground for the 194, so it goes out. When this turns off, it restores the path to ground again, and so it can turn on, and so you get an alternating, they take turns, on, off, on, off, on, off. So what happens when you replace this and this with LEDs? An LED replacement for a 194 does not provide a path to ground, so this floating ground cannot function. When you turn on your running lights, you get power that gets sent to here, and it gets sent to here, and it works here, but because you have no path to ground, the electricity that gets sent here is going to find a path to ground. What it does is it goes on walkabout, and it goes to the wrong neighborhood where it's not supposed to be, and it winds up going through the dash and somewhere finding a path to ground through one of these other things. When it finds path to ground through the dash indicators, then they will light up. So when you turn your running lights on, you wind up with voltage in lights where it's not supposed to be, so lights light up that are not supposed to light up. So why do resistors fix it? They restore a path to ground for this 194 that doesn't exist through this bulb and through its own filament here. So when you add resistors from your running light to ground and from your blinker to ground, you've recreated the same electricity path that exists in the factory setup so that then everything can work just like it did factory. Now, if you're asking, what about the 194 bulbs in the back? Do you need resistors in the back? The answer is no. That circuit is set up differently in the back. These 194s are only running lights. Since they don't blink the way that it works there, you have your 2 1157s, you have your 2 194s. They all share one ground. On my truck, it's behind the driver's side tail light. Since they all share the same ground, these 194s have their own path to ground, and the only voltage that comes in is from the running lights. You've got running light voltage and you've got ground. You can put a 194 in there. It doesn't have to be bidirectional. And as long as you have it plugged in the correct way, then it's going to light up when the running lights come on. The 1157s are the same way. They all light up together. This is all one shared circuit. I think also on this circuit is the license plate lights, which also have their own path to ground. They're just not drawn here. So one filament lights up for your running lights straight to ground, and then you have your alternating blinkers that come in, whether it's right blinker or left blinker, and those also have a path to ground. So the circuit is much simpler. There's no bulbs in series at the back of the vehicle, and so this is much simpler to set up. After lots of trial and error, creating the bench rig to test things without having to butcher up the wiring repeatedly on this thing, these are LED bulbs just plugged directly into the factory sockets with the resistors added to the 1157 in the front grille. As you can see, have the alternating function just like factory with the brightness of LEDs. Hopefully somebody out there who's scratching their head like I was when I first thought I was just going to drop bulbs into this truck and it was going to work finds this video helpful. I did a lot of trial and error trying to get this to work. Once I figured out what the correct solution was to be able to put LEDs everywhere and recreate the factory functionality, I thought it was worth sharing. Thank y'all so much for watching. You can check out my other videos for a whole tour of everything I've done to this truck so far, talk about future plans for it, and hope to see y'all at the next project.